So for these guys, what'd you get? What's 2? Iron, 3 phosphate. Our formula writing is golden. That's a big fat no, right? 5? Cool. Aluminum bromide?
Yes.
I don't see the rule for either.
That's rule 3. That goes to the halides, the binary halides, right? Shh. Lead 2 chloride? That's a big fat no. Lead combinations usually, and you even have probably saw in the news last night, did you see what's going on in Mississippi? There's a lot of lead in their water. And Mississippi's kind of upset because they sent a lot of bottled water to Flint, Michigan, and now they want it back. And it's really very sad because it's like the poorest areas that have a lot of lead in their water, and these are people that don't usually go out and buy bottled water. So I think the country's working together to get a lot of bottled water to this area. It's very dangerous for kids under 5 and for pregnant women. It was on the news last night. All right, so your solubility rules, as I told you the other day, they will be given. You simply have to be able to apply. I don't think you'll have any problem with this. You'll work on E through H during the second half of class. Second half of class will be all problem solving. What our main focus is going to be on today, we've introduced solutions. And our focus today is going to be on concentration. And without even realizing it, you actually have learned, you've worked with different concentrations of chemicals already. For example, in Lab 1-3, way back when in the first 9 weeks, we were working with 1 molar hydrochloric acid and we reacted it with zinc. This was to demonstrate law of conservation of mass. And then in the stoichiometry lab that you did a couple weeks ago, we used 6 molar hydrochloric acid, and this refers to concentration. So I'm going to show you how to calculate concentration. There's a lot of different ways concentration can be expressed. Concentration, in the simplest terms, is the ratio between the amount of solute and the amount of solvent or solution. So your numerator is always the amount of solute. In some cases it's moles of solute, in some cases it's grams, and we'll point out the difference. Your denominator is either the amount of solvent, either in grams or kilograms, or the amount of solution, and solution is solute plus solvent. Typically with solution, at least for molarity, you're dealing with a volume in liters. So the main way we express concentration, this is how I order all of your chemicals, is with molarity. Molarity has a capital M, so when it's said like 1 molar hydrochloric acid, the molarity of your hydrochloric acid was 1 mole per liter. So molarity is moles of solute over the volume in liters of solution. That's the total volume you have, and we're going to talk about how to make solutions today, and then later in the week you'll be doing a lab where you actually get to make solutions 2 different ways, and that'll be good for you to learn how to make solutions and to see the different types of equipment that you use. So we're going to walk through 3 problems. You have to have good formula writing, and you have to really note these units. So in terms of concentration, the first way we're going to represent concentration is molarity. And you probably have seen concentration in environmental management. Have you talked about, for example, parts per million or parts per billion? That's a way that you represent concentration. And what did you talk about it in terms of parts per million? What were you looking at? Salinity. Salinity? So what specifically?
Like the ocean, 35 parts per thousand.
Okay. parts per thousand there. So you can do parts per thousand, parts per million, parts per billion, parts per trillion. And there's a certain, in terms of EPA regulation, you can't supersede a certain number, and it's different for everything that you're looking at in terms of waste, etc. And maybe like phosphate blooms and things like that. All right, so with molarity, capital M for molarity, this is going to be moles of solute over the total volume in liters. Because sometimes when you make a solution, you don't add as much water as you need at the end, because you need everything to dissolve. So it's a little tricky there. We'll go over that in detail. All right, in the first example, and I'll come back to the screen, don't panic. It says calculate the molarity of a solution made by dissolving 2.5 moles of sodium chloride in a final volume of 500 mils. So you're looking for the molarity. You're dissolving 2.50 moles of sodium chloride, that's given, in a final volume, 500 mils. This type of problem is very, very, very easy, much easier than you would ever see, but just to get started. So we want to know the molarity. That's what we're looking for. The moles of solute is 2.50 moles sodium chloride, and the total volume is 500 mils. So molarity, can you see in the back? It's okay. Is 2.50 moles over 0.500 liters. Remember, mils to liters, move the decimal 3 to the left. That should be 5. Watch your sig figs. 5.00 molar. And as I said, that's really too easy. In the lab, how do we determine, what instrument do we use to determine the mass of something? A balance. And what's the unit for mass? Grams. Do we know how to convert from mass to moles? We sure do. So that's what you're going to be looking at in the next problem. So in the next problem, it says calculate the molarity. We have 24.8 grams of lithium sulfide. Final volume given. So let's get our variables down. We want to know the molarity, the mass of solute, 24.8 grams. I know molarity is moles of solute over the total volume in liters. So what do I need to do? ahead, Cindy.
Grams to mole.
Absolutely. How do I do that?
You calculate the molecular mass of lithium sulfide.
Right, and it's formula mass only because it's ionic. How do you know it's ionic?
Because it is a metal non-metal.
You got it. Good job. So you have 2 lithium. So 2 times 6.941 plus 32.066. So there's our moles. What about the volume? Use it as it is? Change it to liters. Move the decimal. 3 to the left. That's the concentration, 0.720 molar. Sometimes we'll write it like this. Lithium sulfide concentration, those brackets mean concentration. How we doing? Mason, you got it? Easy, easy? Okay. If this is your formula, what if they asked you to solve for mass? What if they wanted to know what mass of substance would you dissolve in water? How would you go about solving for mass?
Move the VT to the capital M,
Okay,
and then you would find out the mole, and then you go from there.
you got it. So you would solve for moles by multiplying the molarity times the volume, and then you would convert to mass using the periodic table. That's typically how you would be asked. When I need to make your solutions, for example, if I need to make a 1 molar lithium sulfide solution, if I know I want 1 liter of it, I can figure out the mass of lithium sulfide that I need to add. And that's what we're going to look at in the next problem. And that very often is the way it's done. And that's what you do to make up solutions. And you'll see in your labs coming forth, I have a lot of review questions in there to make sure you're remembering how we did previous material. So in number 3, and this is what we were alluding to, it says calculate the mass of sodium perchlorate. And it's dissolved in 100 mils of solution to generate a 0.5 molar solution. And you'll see that I very often abbreviate solution SOLN, so I indicated it there. So we want to calculate the mass of sodium perchlorate that's dissolved in 100 mils of a 0.5 molar solution. Okay, so we want to calculate the mass of sodium perchlorate. The volume is 100 mils. We've got to get that to liters. Move the decimal 3 to the left. And we want to generate a molarity of 0.500 molar. And remember that molar is moles per liter. And if you write it out initially, it may just help you with your unit cancellation. So as Rayanne said earlier, she said, well, you should go about doing it solving for moles first. That's exactly what we're going to do. Moles of sodium perchlorate is equal to the molarity times the volume in liters. So we have 0.500, and this is why I said if you wrote the units out, you might see the cancellation. The liters will cancel. And you've got 0.0500 moles of sodium perchlorate. But they asked for the mass, and this is where I think some kids went wrong on, some kids went wrong on the quiz. That's moles. In your gas laws, that's represented with an N. So if you want to get the mass, what do? How do you convert that to mass? Periodic table. Formula mass of sodium perchlorate, 22.99 for sodium, 35.453 for chlorine, 4 times 15.999, 122.439 times 0.05, and that's 6.12 grams. So you have to be comfortable with molarity. Molarity is moles per total volume in liters. You can calculate molarity, you can calculate moles, you can calculate mass. You can do any variation in there. And in your classwork there are 5 practice problems on molarity. Molarity is what we tend to use the most in the laboratory. It's the one that you definitely want to be familiar with. This is one way to represent concentration, and it fits into our overall learning goal that we mentioned the other day. And I'll flip them once we get through the gas test. I just didn't want to take time. Okay. So concentration, this is going to be a way that we express units in terms of solution, moles per liter of solution. Questions here? Doable?
Wait, so when you're writing concentration, you write like the lithium one?
Yeah. So in here I wrote molarity, but I could have done this. It's more commonly written like this. You'll see that a lot in textbooks and quizzes upcoming. Not quite yet. You're not quite ready for it yet. But like in AP, we titrated, and we use different acids and bases. For example, the concentration of the hydrochloric acid we used was 0.100 molar, and we used ammonia. Let's say it was 0.500 molar. You used hydrochloric acid this year. You used it at 1 molar, but you also used it at 6 molar. And what you'll see shortly is that 6 molar is more concentrated than 1 molar. 1 molar is more dilute than 6. And we'll talk about that in a little bit. You'll be making solutions, figuring out their concentration, and then you'll dilute them like 3 times and figure out their new concentration. Alright, so molarity is moles of solute per total volume of solution. Now just be careful, it is that total volume, so if you initially added 600 mils of water, but you brought it to a final volume of 800 mils, your total volume would be 800 mils, so it's that final volume that you use in the denominator. Alright, another way to represent concentration is molality. It sounds similar. This is a lowercase m. You'll be using molality quite a bit with the colligative properties toward the end of the chapter. This is moles of solute per kilogram of solvent. Please remember that 1 kilogram is 1,000 grams, because you might be given the solvent in grams and you'll need to convert to kilograms. So molality is moles of solute per kilogram of solvent. And we're going to walk through these 3 examples here so that you're comfortable calculating molality. Like I said, this is very, very mathy, very straightforward. You're going to be very good at this. It says calculate the molality or molal concentration. You can write it either way, so don't be upset if you see it, written either way there. You're going to dissolve 63.9 grams of magnesium acetate in 3,000 grams of water. So magnesium acetate is your solute, that's what gets dissolved. Water is your solvent, that's what does the dissolving. Okay. So in the first problem, we want to calculate the molality mass of magnesium acetate is 63.9 grams, and the mass of water, this is the solvent, this is the solute, is 3,000. The molality is moles of solute over kilograms of solvent. So we need to convert this to moles. Be careful with acetate. It's commonly used because it's soluble, but it may be easier here to combine C2H3O22 just in terms of the counting. So you've got 1 magnesium, 4 carbon, 6 hydrogen, 4 oxygen. Oops. And that's 0.449 moles magnesium acetate. What do we do next? wanna get it to kilograms?
Yeah.
Okay, so move the decimal 3 to the left, or divide by 1,000.
Yeah.
So that's my denominator, and what's my numerator? Right there. So 0.449 divided by 3. Moles per kilogram, or 0.150 mole out. I'll take it either way. But that's why I don't allow little m for moles, because it doesn't work. Pretty good? I'd like you to try number 2. Number 2 is grossly similar. 3 is a little different, but 2 is grossly similar. I'll put 2 on the screen in just a sec. All right, on number 2, you want to calculate the molality. You've got 42.6 grams of lithium phosphate. You have to be able to formula right. You're very strong with that. 720 grams of water. Give it a shot. Who sits in front of Ashley?
Sarah.
She's sick. 2, 4, 6, 7, 10, 14, 16, 20, 3, 6, 7. To Sarah. actually gonna put all of this on online for period 2, so it works out pretty well for you. I don't think the video is gonna work. The video, I think, will be terrible because I can't talk.
Thank you.
Have fun. Say hi to Mickey for me.
Wait, is everybody doing cookies?
No. Taylor's leaving, so the rest of you can hold back on your little cookies. Okay. I don't know, just leave it for right now. I don't really like any peanut butter in my room because I have kids. I know I have a kid allergic first hour.
How do you go from grams to
Grams, okay. No, you don't need this. Guys, let's look at number 2. On number 2, you got moles, right? And you divide by kilograms. Remember, molality is moles of solute per kilogram of solvent. Guys, I really can't talk loud. If I have any more of those suckers, my tummy is gonna just, it was like, I must have had 10 of those Ricolas yesterday, and they're sugar-free, and my tummy hurt so bad last night. Well, because it makes your tummy rumble. I sounded like Winnie the Pooh. So I'm trying not to have too many, but then I can't talk. Then I gag.
Is it like strawberry granola ones? Those ones are good.
I don't know.
I eat those at
I think I just really want to go to bed. Shh. Yes? Mason, what time to go to bed? I went to bed at 11 and got up at 1.
how'd you get up at 1?
I'm awake, so you need to be awake. You don't want to stand again. You can do this, honey. All right. Shh. Shh. I couldn't sleep. Can't breathe. Shh. No. My son woke up around 1. So we play. Easy peasy. All right. This one's a little bit different. It's not that I'm going to give you one like this, but if you can do this, you really can do anything. It says calculate the mass of water in grams. So we're looking for the mass of the solvent required to dissolve 121 grams of sodium carbonate. And you want to generate a 0.713 molar solution. So this one's a little different, and you're solving for the denominator, so you need to be careful here. And again, the formula writing should not be an issue at all. We give you the molality. So we know that molality is moles of solute over kilograms of solvent. So what we're doing in this one is we're solving for kilograms of solvent, and then we can convert to grams. You're math savvy enough to know you can interchange those two variables. So kilograms of solvent, moles of solute over molality. What do I do with these grams? Convert to moles. 1.14 moles. I'm going to divide it by this. I get 1.60 kilograms of water, but they asked for it in grams. So that's 1.60 times 10 to the third grams of water. I just multiplied by 1,000 or 10 to the third. I don't think I really gave you anything like this. This one's a little bit harder, but you'll see that on your classwork, and you should be able to do it. Okay? And we're going to revisit molality in great detail when we talk about boiling point elevation, why salt water boils at a higher temperature than just water, and freezing point depression, why they salt roadways up north during the winter. Okay. There are two more pieces we want to do. We've got molarity, we've got mole fraction. What can't you read? This is 1.60 kilograms of water, 1.60 times 10 to the third grams of water. Just multiplied by 1,000, but to watch sig figs I had to go into scientific notation.
So it's the pink answer, not the blue, or the purple?
The pink is the correct answer.
So because of sig figs, you can't just move the decimal over 3?
No, because you only have two sig figs.
Alright.
I think that happened on one of the forms of the quiz too. Okay? Alright, we have molarity, we have molality, and we'll make a running list of formulas for this chapter because there's a lot of them. Another way to express concentration is mole fraction. This one's pretty easy. Mole fraction is moles of solute or solvent in the numerator over moles of solution in the denominator. So moles of solution is moles of solute plus moles of solvent. So if they give you grams, you have to get moles of each and add them together. Mole fractions represented with an X. If you want the solute, you're going to put the moles of solute in the numerator. If you want the solvent, you'll put moles of solvent in the numerator. One example up here. It says calculate the mole fraction of the solute when 61.7 grams of barium nitrate is dissolved in 130 grams of water. Let's take a look. We want to calculate the mole fraction of the solute. In terms of solute, we have 61.7 grams of barium nitrate. And in terms of the solvent, we have 130 grams of water. So mole fraction of the solute is moles of solute over moles of solution. Watch the denominator. That's where the mistake usually comes in. We want to convert this to moles. then we also have to work with the solvent. We have 130 grams of water. 1 mole of water is 18.0148 grams of water. We remember that from hydrates. And let me just make it really clear with the denominator. I'll show you where the kids make the mistake. The moles of solute is 0.236. The moles of solution, you have to add the two together. What's the unit for mole fraction? Remember in the beginning of the year with the unit for RF, we had centimeters over centimeters and there was no unit? So this unit cancels too, so mole fraction doesn't have a unit. I don't know why I only gave you one problem there. Let me give you another one. Pick a compound, any compound. Pick a compound. What's soluble?
Cesium chloride?
Okay.
Dude, that's my favorite compound. Oh my gosh.
You're so silly.
Oh my gosh.
Try number 2. Cesium chloride. And I asked for the solvent, so you got to put the solvent in the numerator. Say it again. Cesium chloride. It's on the screen.
I stopped.
Is it too small?
Yeah, I'm scared.
Is that better?
Solution, I can't get the moles of solution. I know the moles of solute. That's weird.
What's cesium? Like 132 or something?
So then would you put, this is the moles of solute, so would you put that on top? Okay, so then, okay. How do I feel like what is the answer to this question? Oh, it's just a mole fraction. Oh, that's the one. Dr. Kayla's, was it 0.031?
I didn't finish it.
No, for number 1.
0.0316.
Yeah.
What'd you get?
Wait, I'm sorry. Okay, guys.
Point what?
I said
I got .974.
I got,
Oh no, I got .973 also. I didn't look at it right. That's right. But what?
Hold your pencils.
What?
Right?
I'm hold it, yeah.
It looks, it's like you're writing with a feather.
It's hard to tell if this is straight.
Yeah. For that.
All right, I had wanted to do another section with you. I just can't. I can't do anymore. And I think you've had enough anyway. I don't want you to confuse these. I want you to master these 3 concepts on concentration. So, after cookies, classwork 3.3, you can do through number 11 now. You want mastery of that. On 3.3S, which is the portrait classwork, you can do part 1. That's what we did last time. I will get your quizzes back to you. A lot of you in here got high 90s, so you really get it. And some of you in here got in the teens, 20s, and 30s, so you really need some help. You are welcome to seek out help from me, or if you'd rather seek out help from your classmates who scored in the 90s, that's fine. Your test is Tuesday. After your test, we'll do dilution, and that'll get us ready for the mini lab.
I have to do the graph and answer number 6.
Say it again. You want to see the first one?
I have to do that one graph. I don't even know what it is. Yeah, I'm just